My name's Leonard Mitchell. This is the final demo for the Group 3 optical project. Here we have the stereo camera system consisting of two 400mm focal length telephoto lenses inside each tube, with our large 2-inch achromat in the front section held in with a retaining ring, and in the rear section inside this focuser we have the negative lens, creating the two lens optical system. The focuser on the back of both of these lenses is used to adjust the focus of the system for objects that are different distances, and on the back of the focuser is our stereo cameras. From the rear we can see the platform that the cameras are mounted to, with a separation of 28 centimeters between the center of each optical system, which provides the baseline measurement which we'll use in the calculations during demonstration. Unfortunately, ideal would be to have a much wider baseline. However, due to the plastic materials and 3D printing quality and the Florida heat, we had to shrink the baseline to this to make sure that we could maintain alignment of the cameras and provide stability without any warping or changes to the structure of the system. To perform the image processing, the stereo cameras are sent directly to my laptop, where we're using OpenCV to stream and capture the images. What makes this nice is that we can see the stereo image set with a live video feed, and from here we can capture our images with a simple control of the C button. Here we have a drum barrel that is approximately 180 to 200 meters away, and we can see that we have the same features of the barrel captured in both the left and right image. So what we're going to do is capture 10 images by using the C button on the keyboard, and then we will use MATLAB to perform our image processing, trying to pick similar features of the oil barrel to create our disparity and final calculations. Unfortunately, part of the outside demonstration is we can't control for traffic and other variables. So here we have an example of a captured left and right stereo image, which we are going to put into our MATLAB calculations to figure out the estimated distance of the oil barrel in the images. Okay, so now we're in MATLAB. We're going to use the code in here to calculate the disparity of the oil barrel within the stereo images by picking pixels of the same feature of that oil barrel in the left and right image, and then based on that pixel location, calculate the disparity, and then using the focal length of the lenses and the width of the platform the cameras are on, calculate the estimated distance. Everything is already inputted to pick up the first stereo image we captured earlier. So we're going to run the code. So first thing we have to do is select a feature in the left image. We're going to pick this small corner protruding from the oil barrel here, because we can see that same feature here in the right image. And the MATLAB is going to give us the disparity, which is the difference in position based on those two pixel values. That's the selected X coordinate from the first image. Here's the selected coordinate from the right image. And here below we have a calculated disparity in meters using the pixel size, well, I should say average pixel size, because we're not in full resolution with the camera, and then the estimated depth measurement, which is unfortunately not accurate with this system, largely because we can't run full HD with the cameras because the computer can't process both cameras at the same time. Additionally, the baseline is too narrow because of the material issues and the heat, which prevented us from creating something wide enough to hold the cameras as well as provide the necessary stereo image overlap. That is a demonstration of the system.